Hey, what's up, everyone? Today I just want to talk a bit about using tyFlow particles, or really any kind of particles, as Phoenix emitters. Before we begin, please note that this is not a tutorial about this particular effect, or any specific effect. It's just a guide on the relationship between the two systems. I've seen quite a few people run into issues while trying to emit fluids from tyFlow particles. Sometimes it feels like things just don't work, or the setup starts behaving in unexpected ways. Alright, let's jump right in. Here's a simple tyFlow system. A bunch of particles are generated right at the root of our scene, the home grid. They shoot outwards in every direction, slow down over time, then stop and disappear. Here's what the flow looks like. I've added a birth operator that spawns 200 particles over a period of 200 frames. A shape operator assigns a shape to each one, just a low-res sphere. There's a speed operator that sends them flying in random directions. Without it, they'd just sit still at their birth position. A slow operator brings them to a stop after a while. And finally, a delete operator removes them once they're stationary. Right? If the velocity magnitude drops below 0.1, that triggers the operator and the particle gets deleted. So yeah, as you can see, it's a really simple setup, nothing fancy, just enough for testing and experiments. There's also a Phoenix simulation grid already prepared. It's using all the default settings. I didn't change a thing. I just created it beforehand to save us some time. Now all I need is a Phoenix source node. I'll pick a fire source from the toolbar and place it somewhere in the scene, here, for example. All right, switch to the Modify panel, press Add, and click on the tyFlow node icon. Right, that's it. I could start the sim now. But nothing's happening. No emission at all. So why is that? Well, right now, Phoenix can't find anything inside that tyFlow node to use as an emitter. It can't see any polygons, and it can't access any actual particle data either. One way to fix this is by adding a mesh operator to our flow. Typically, this operator is used to build the particle's geometry at render time. You need it if you actually want to render and see the particle shapes. It creates triangulated meshes by default, and that's something Phoenix can use to emit from. However, it only does that once you hit render. We need that geometry available while Phoenix is simulating, though, so make sure you uncheck the render-only checkbox. Now I can resume the sim, and there we go. Now we're getting some temperature emitted from the surface of the geometry. Also, some smoke. It rises because of the heat, and it seems like everything works as expected. If you forget to uncheck that box, like I do most of the time, Phoenix simply has nothing to work with. All right, let's stop this and go back to frame 1. So we got this working. However, if you select the source and scroll to the bottom of the rollout, you'll notice that the particle control options are still inactive. That means we're still not actually using any real particle data. We're just forcing tyFlow to create some geometry in the scene that Phoenix can use as a geometry emitter. Right, we'll change that in a minute, but before we do, let's explore this method a bit more. I'll disable this flow for now, and in here I've got a simple cylinder. This cylinder has polygon ID1 on the top cap, ID2 on the bottom, and the sides are assigned ID3. That's how cylinders are built by default in Max. If you create a new one and turn it into an editable poly, yeah, ID1 is on top, ID2 is on the bottom, and ID3 on the sides. So I'm using just a standard simple cylinder. Let's turn it into a particle using the birth object operator. Pick the cylinder and there it is. Now, hide the original shape, right? And don't forget the mesh operator. I always forget about it. Uncheck render only. Select the source again, scroll to the polygon ID option, and set it to 3, for example. Start the sim, and yep, only the sides, ID3, start burning. You can change that, of course. The point is, the geometry created by tyFlow carries over the correct polygon ID data from the original object, and Phoenix can still read and use it. So yeah, you can fracture this object, assign specific IDs to the fractured faces, and use those to emit dust inside the cracks, for example. And, all of that cool stuff. However, technically, you're still not providing any actual particle data to Phoenix. it's still using polygonal geometry. The particle controls at the bottom are still inactive, which is fine. But let's see how to change that. Select the tyFlow object, open the interfaces rollout, and enable the particle interface. This makes the particle system and all of its cached data available outside tyFlow and visible to the rest of 3ds Max. Now Phoenix can finally access it. Pick the Phoenix source again, scroll down, and there it is. All of the particles related options are now activated. Here's what's happening now. By default, Phoenix creates a small spherical emitter, 1 voxel wide around each particle. In other words, the voxel that each particle occupies will start filling with smoke. And temperature too, if it's enabled. In this case, you don't even need the mesh operator anymore. You can switch it back to render only or disable it. You can even delete it if you are not planning to render these particles. Phoenix doesn't need it anymore. It now creates its own 1 voxel wide spherical emitters, using each particle's position data. If you want the emitter to be larger, you can try switching it to use the particle size. It's the second option from the dropdown. However, the result might not be what you expect. The cylinder we turned into a particle is obviously much bigger than the emission area. There's a reason for that, but it's probably not what you think. This can be confusing and even a bit frustrating. Believe me, I've been there. This option requires a more thorough explanation, so we'll take a closer look at it in a minute. For now, let's just skip it and come back to it later. Moving on, the next option is to set a custom size for the spherical emitter. This enables the size input field, and it is in scene units. My scene uses centimeters, so it's 2 centimeters by default. You can make it a lot bigger, of course. There, much larger now. Okay, let me restart the simulation because we almost reached the end of the timeline. The last option we have available is to use the shape of the particles. Select it, start the sim, and yes. Even with the mesh operator disabled, Phoenix can now look directly at the cached particle data and see the particle shape. And what's even cooler, the polygon IDs are still coming through, and Phoenix can use them too. How cool is that, right? Different approach, but we're getting a similar end result. With the first method, we let tyFlow build the geometry through the mesh operator, so Phoenix can use it. With the second one, Phoenix reads the cached data and extracts the geometry created by a shape operator, or, in this case, by the birth object operator. Oh, by the way, speaking of cached data, make sure everything you want to access, like shape info in this case, is actually being written into the cache. By default, the shape is included, so you're good. I can't really say which method is better or faster. It depends on your scene, I guess. The actual tyFlow setup, the particle count, and so on. Honestly, I haven't noticed any big performance difference so far. However, one advantage of using particles as emitters instead of geometry is that you get access to the particle age. That means you can animate your Phoenix source and switch the time base from the absolute timeline to a particle age-based timeline, if that data is available, of course. By default, tyFlow doesn't export particle age. So again, go into the cache rollout of your tyFlow system and enable it. Here it is. You'll notice the cache size goes up slightly. This means that some additional stuff is being written. In this case, it goes up just a tiny bit. But with tens of thousands of particles, it can add up quickly. So enable it only when you actually need it, all right? Okay, let's take a step back for a second and look at that second option again, the one called Use Size. Yeah, this one, the second one in the dropdown. The name kind of suggests it'll somehow figure out how big each particle is and create an emitter that matches that size, right? However, if I choose this option and start the sim, it looks like there's just a small emitter created at the particle's position. And it's slightly bigger than the one created by the 1 voxel option. So, something's off. Let me zoom in a bit and maybe hide the particles from the viewport. Also, let's disable the GPU preview. Maybe that'll help us see the smoke better. Perhaps make it a bit brighter. Yeah, okay, that's better. So, this is the 1 voxel wide emitter. And with the Use Size option, we have an emitter that's maybe a bit larger. Let's check the Phoenix grid resolution and see how big 1 voxel actually is. Yeah, 1 voxel is half a centimeter wide, and the emission sphere from this option seems a bit bigger, probably around 1 centimeter. Let's do a quick test. I'll switch to Custom Size and set it to 1 centimeter. Yep, It looks about the same. Actually, let me disable the temperature. Might be easier to see like that. Okay, this is with a 1 centimeter emitter. I'll switch it to use the size of the particles. But it looks like it is the same size. Nothing has changed. So let's keep digging and try another experiment. I'll delete the cylinder from the birth object operator. And let's create 2 spheres instead. I'll make this one smaller, maybe 3 centimeters. And this one, let's go with 10. Something like that. Move this to the side so it's not in the way. All right, let's turn these 2 spheres into particles. Okay, hide the original objects. Yeah, that should do it. Let's run the sim. And yeah, the emission is happening inside the spheres. Let's hide them. There. There are 2 small emitters right at the centers of the spheres, but they are the same size. Let me double check if we are using the Use Size option. Yes, we are. But the emitters are the same size. That's weird, right? Okay, let's add a Display Data operator and see what's going on. This shows the particle IDs, 0 and 1. Might be hard to see. Let me pick a darker color for the particles. All right, that's better. Now, I don't really care about the IDs. I want to see the size of the particles. We have the age, position, scale, but that's not what we need. I can't see a size checkbox anywhere in here, but there's radius. Let's display that. The first one shows a radius of 10. The second one, 3. Are those the values we used? Yeah, exactly. They match. All right, that's something. Actually, let's also look at the scale values. And it's 1 for both particles. Can't zoom that in, unfortunately, but hopefully it's visible in the video. Anyway, the scale is 1 for both spheres, despite the fact that the one is significantly bigger than the other. And this might be our first clue about what is going on. Let's try adding a scale operator and throw in some variation, okay? Make it uniform, set variation to 100%. And maybe I should clear the Phoenix caches just in case. Okay, let's play with the seed value a bit. Maybe we'll get a more interesting result for our test. Ah, this might work. Let's see. So this one, the larger sphere, now has a radius of about 1.5, scaled down to 0.1, around 10% of its original size. The other one's also smaller than it used to be, about 2.6 centimeters now, scaled down to roughly 80% of its original size. And now it appears bigger than the other one. Let's see if I can reduce the number of decimals on screen. Oh, I wish I could make those labels bigger. But anyway, let's run the sim and see what happens. Maybe re-enable the GPU preview, or even hide the particles again. There we go. So, we've got some emission happening inside the smaller sphere, and nothing over here where the bigger sphere used to be. Actually, let's try another seed value. Or maybe just scale both spheres up, say 400%. Yeah, that looks better. The bigger sphere is now almost twice as large. Its scale is about 1.9. But the smaller one, even though it's half the size, is scaled up about 3.5 times. So if I restart the sim, you can see the smaller one has a larger emitter because it's scaled more than the other one. The left one, the bigger one, isn't scaled up that much, so its emitter is smaller. I hope that makes sense. So it seems Phoenix is taking the scale value of the particles and converting that value directly into centimeters, making a 1.9 centimeter wide emitter for the left one and 3.6 for the right one. Yeah, but why? At first, I honestly thought this was a bug, but if you open the cache rollout in tyFlow and take a closer look, there's no size, no radius, nothing like that stored. Scale is the only one there. So unless I'm missing something, there's really no other way for Phoenix to figure out the actual size of the shape, other than using the shape itself. Yeah, but this really brings up a question. If we can access the particles' shapes anyway, why do we even need the first three options? Can't we just always use the shapes? Well, there's more than one answer to this, and one essential reason is speed. Imagine you have thousands or tens of thousands of tiny particles. It would be considerably faster to let Phoenix read their positions and create simple, optimized spherical emitters instead of processing and voxelizing geometrical objects. Also, the objects could be really small, smaller than a single voxel. There's a good chance that the emission fails, if that's the case. If you have tiny dust particles, for example, like in this scene, for instance, there is this fine-grained debris, almost like sand. They are definitely smaller than an individual voxel, but I was able to set them as one voxel-wide emitters and run a quick simulation without caring about their geometry. The second important reason for having these first three options is that the particles might not even have a shape. Maybe it wasn't exported, or perhaps there was none in the first place. Let's take a look at this example. It's a simulation I made a while ago. The emitters that I used are not tyFlow, but Phoenix splash and mist particles. They were generated and cached by a Phoenix liquid simulation, and then used to emit fuel in the scene, which gradually catches fire. These droplets never had shapes assigned to them, and the mist was actually never visualized in the renderer. They only served as invisible fuel emitters. And by the way, there's a detailed video tutorial about this Molotov cocktail explosion. It is not on this channel. I uploaded it to Chaos TV a few years back. I'll leave a link in the description if you care to watch it. Anyway, let's go back to our tyFlow guide and see how we can use only particles that are in a specific event to emit from, and how we can use a single flow with multiple Phoenix emitters. Let's disable this flow and clear the Phoenix caches. Go back to the previous setup and modify it slightly. I'll disable the delete operator and the speed operator, like this. I can add a position icon operator. Create a new icon. I'll use a sphere. Make it a bit larger. Right now, the particles are positioned on the surface of that sphere. It may be better if I make them occupy the entire volume. Okay, that's better. Let's change the birth range so that all of them are generated right from the start. We actually don't need the speed and the delete operators or the slow, and let's get rid of the mesh operator as well. Let's check how big these particles are. Seems like the radius is 0.5 centimeter. Okay, let's randomize this with a scale operator. 80% might be a good value. Also, make them a bit bigger. Okay, this looks good. We have one over here that has a radius of 1.4. We can use this to split some of them into a new event. A property test might do the trick. Set it to look at the radius. Okay, so if it is above or greater than, let's say, 1, they are sent into the next event. Let's change the color so that it is clearer. Cool, we don't need this anymore. Now the smaller ones stay in the first event, and the bigger ones are moved into the next one. Maybe I can change the threshold? 0.7? Nah, the other way around. 1.5 maybe? That's better. Okay, these are the two events. Move this one out of the way. And let's say we want only the smaller particles to act as emitters. We can add a group operator. In here, we can change the simulation group, but also the export group. Enable it and tag these as particles A, and the big ones will be particles B. Starting the sim now, we'll still use all of them as emitters. The ones that aren't scaled that much have smaller emitters, and the larger ones will have bigger emitters. Because we're using the particle size option, which makes a lot more sense in this case. Okay? Now, we want only the small ones to emit fluid. We can go into the interfaces again and enable it only for the A particles. Particles B will stay behind the interface wall, and Phoenix won't be able to see it. You can have both, of course, or just the B particles exposed. In other words, the ones that are not visible through the interface will remain hidden from Phoenix. But what if we want to have each group assigned to a separate Phoenix source? Let's say we want the small ones to burn hot and the large ones to emit cold smoke that goes down. Let's copy this source. When you do, the emitters list is cleared. When we try to add the same tyFlow system back, Phoenix will pop a warning that this node is already in use by another source, and one of them will be ignored during the simulation. This is not what we want, so let me remove it. And think of a workaround. Let me make this window a bit bigger. Okay, so we have two events, particles A and particles B. This system could be left as a main or master system. All right, let me clear the Phoenix caches so we can see it better. In this master system, we can change whatever we want, perhaps generate fewer particles. Okay, so what I can do now is to create another TIFFlow system. And I can add a birth flow operator. In here, I can pick the original TIFFlow object, the master source. All right, all of the particles are now copied into the new system. But in here, you can choose a specific group that you want. Let's pick the A particles. That way, we're left only with the small particles inside the second system. I can now create another one, copy this event, paste it in here, and get only particles B. You can now hide your main flow. You can still edit it, of course, if you want to tweak something. If you're going to have more or fewer particles, the two new TIFFlow systems will update accordingly. Now for the first Phoenix source, you can remove the master flow, which contains all of the groups, and add the first system, which only has the particles marked with A. In the second source, choose the flow that has the particles marked with B. Now you can dial in different settings for each Phoenix source. Let's say we want this one to emit colder fluid, 100 kelvins, for example. The smoke should fall because it will be colder than the environmental temperature, which is 300 Kelvin. So yeah, let's see if it works. Oof. No, of course not. These new TIFFlow systems need to have their interfaces enabled as well. And it looks like it is working. There's some smoke rising up and some going down. There are too many particles, though. Might be hard to see. Let's try with just 5 particles. Okay, it is way more obvious now. Okay, I hope that this information was helpful. Before I wrap this video up, let's take a quick look at this scene one more time. It's a TIFFlow setup that is currently disabled, because I don't need it calculating at the moment. Here's where I import the object. It is a single cube primitive with a physics shape applied. It goes into the next event when it reaches the floor, where it is being fractured. The pieces that are closer to the floor are being fractured again into a series of other events. Nothing too complicated. You can find tons of tutorials on how to do that on the internet. Here I have an export operator, which I used to write a tycache. Unfortunately, the tycache export option is only available in the professional version of TIFFlow. If you don't have the pro version, then you can try exporting it as an alembic file. Here you can see which channels are being exported. After the export, I stop this flow so it doesn't keep calculating and slowing my scene down. Here I have the tycache loader that reads the exported sequence. In the elements rollout, you have the particle interface available as well. I kept it disabled for this instance of the loader because it is going to be used only for rendering. Here you also get the simulation groups for the specific events. The groups are added the same way that I just showed you, and that info was also exported. So you can isolate the groups or hide a specific one if you need to. This object was used for rendering only, as I already mentioned. So I added it into the exclude list in the scene interaction rollout of the Phoenix simulation. I didn't want Phoenix to interact with it in any way. In the colliders layer, however, I have 3 copies of that same tycache loader. I isolated the big pieces in one of them, the smaller grains in another one, and the fractured chunks in a third one. And if you end up using alembic files instead of tycaches, you might have to export 3 different ones. I have 3 separate Phoenix source nodes. This one is emitting from the bigger chunks. They are treated as geometry, not particles. The emission happens on ID 2. Those are the polygons created by the multifracture operator. The next one is emitting from the grain particles. And the emitters are 1 voxel wide. It generates a smoke amount of 3, injecting it in the scene with a power of 35. And the last source is using the small chunks. In fact, these are the medium-sized pieces. They are also treated as particles. This time, they are set to use a custom size emitters of 1.5 centimeters. They produce less smoke than the grains. The smoke amount is 1. So, yeah, 3 copies of the TiCache loader having different settings, and each one being used as an emitter object in one of the 3 Phoenix sources. Okay, I think that's pretty much all I have to say. As always, thanks for watching. I do appreciate any comments, so do not hesitate to drop one. Take care, and hopefully see you next time. Bye.